Hello everybody, good morning. I will tell you something about our research activity in Technical University of Civil Engineering. I did this work with my students, PhD students and also master students. And it's about natural refrigerants study. It's a theoretical study. And also you can see about this work we did and we tried to solve in our country, also with the Romanian General Association of Refrigeration. Here is our country, Romania. We are neighbors, but we are EU members, and that means that we have to respect EU legislation, and it's very important, this 517/2014 regulation. In this regulation we have to phase out some refrigerants, fronts, and we try to introduce natural refrigerants in new systems like CO2 and hydrocarbons, and also to continue to use ammonia because we are ammonia traditional user. We signed, of course, Kyoto and Montreal protocols, and we have to respect this international legislation. About ammonia, in Romania we have many refrigeration systems in food industry working with 404A, 134A, and also with CO2 and ammonia. Starting 2020, 404A, we have to phase out in new refrigeration systems. You have here some examples of our refrigeration system for food industry, for slaughterhouses, storage room, logistic parks, warehouse farms, beer factories, poultry slaughterhouses, dairy factories, wine factories, and of course supermarkets. And here you have in all our 8 regions where we did this, and also you have an example of the biggest logistic mega image, Stefanești, was built with ammonia and is covering more than 4 megawatts cooling capacity. It is important to know that those of Basic were built with about 50% using European financial support. You can see here in food industry more than 90% was used for storage because we imported a lot of these foods, and between 2 and 5% in other fields like poultry farms, warehouses, slaughterhouses, chemicals, drinks, fruits, vegetables, and many others. You can see here some examples of this efficient refrigeration system working with screw compressors, and some examples from these refrigeration systems from our country. About CO2, this was introduced in the last 5 years, and there are 2 types of refrigeration systems: cascade, hybrid more than 70%, and booster about 30% as critical with CO2, with conventional equipment. And you have here some examples, and the cascade is working 80% with 134A and CO2. Again, you can have some examples from this kind of refrigeration systems. For cascade, we used in all 8 regions of Romania. We have the name of the city, the surfaces, refrigeration capacity and freezing capacity. We can see that we use more for fresh products, refrigeration capacity. The first supermarket cascade system was built between 2012 and 2013 in Bucharest with carrier house Raptor products. German design. Today we have more than 100 such systems, and these were built with Romanian intelligence and you can see here some companies, Tecnical, Refrigeration, DAS, Romanian. And also some cities where we build these kind of systems. About booster system, first supermarket booster system was built in 2013 by Tecnical, belonged to Carrefour hypermarket Galați, and after 2014-2015, DAS and Tecnical built and improved other systems with transcritical CO2 for Carrefour Constanța, Ploiești, Megamall, Vulcan, in Bucharest, and many others. In the present, we try to retrofit these systems and buildings and to introduce CO2 in Romania and also abroad with Romanian Working Intelligence. It's very important, this example, in Galați, the transcritical new hypermarket, we have a higher efficiency refrigeration system. We use recovery and also preparation of hot water for heating and sanitary purposes in the hypermarket. In 2016 was built the first supermarket pump system in the southeast part of Romania in SLUČAJA. It was a bakery. This is also with Romanian intelligence. One of my students designed this system. With my students, I try to simulate first theoretical with back calculation program, and we have an experimental setup working with 404, and we try now to make comparison between this and other systems, work with CO2 and ammonia. The refrigeration system is a classical one with modulation technology to minimize continuous modulation of refrigeration capacity. The cooling capacity was about 100 kilowatts, condensing temperature to 25, and evaporating temperature -10. We calculate total equivalent warming impact respecting standard 378. You can see here the simple technical drawing with those compressors, evaporators, and condenser. And here you can see after the simulation results to compare total equivalent warming impact between 404A, CO2 and ammonia. We can see that the best alternative is ammonia with lower total equivalent warming impact. Also, we simulate energy consumption, and we have here energy consumption comparison between 404A, ammonia, and CO2. We can see here again that with this a yellow color, that ammonia is the best alternative. Also, for life cycle costs, ammonia is the best, lowest costs. So, in conclusion, after a global analysis on the Romanian refrigeration situation, it could be said that our country remains a traditional ammonia user. And making analysis on the Romanian market in the last 4 years, it can be concluded that the most important field where the ammonia was used was food industry. Also, we introduced CO2 in the last 5 years, and we use cascade and also transcritical systems. And in the theoretical cases, because we try first to make research to improve and to retrofit this kind of system working with 404A, in our university, the conclusion was that the main disadvantage of CO2 are high condensing temperature and pressure in comparison with the 404A and ammonia. And about ecological conclusion, ammonia is the best, global warming potential 0 and ODP 0, and also the lowest total equivalent warming impact. And for the point of view of energy consumption, also ammonia was the best. We are doing also in our country a lot of training courses to introduce this alternative, natural alternative, training for natural alternative, and also for life care regulation. We have also very good cooperation with private sector and also the Minister of Education, Environment and Economy, and also with standardization organization and of course with universities. Cooperation with universities, that means we are doing a lot of research projects in the field of refrigeration, thermodynamics, heat and mass transfer, heat exchangers, experimental models and the experiments implemented before, EU refrigerants and EU legislation about that. We wrote a lot of research and also books and code of good practice, eco-refrigeration and the legislation about that, environmental legislation regarding the fields of refrigeration and thermodynamics and many others. We have laboratories and the research team of our association and the private sector and the university develops its works in national and international research projects. One of these first step I just shown you today. If you need more information, don't hesitate to ask. We have this email address in the association and also from the university I can give you. Thank you very much for your attention. And if you